In this episode, a California company begins building a Hyperloop, and scientists look to plant systems to more efficiently power robots. Welcome to your Manufacturing Minute. The race to be the first company with a functioning Hyperloop has been ongoing for years now. But last week, one startup, Hyperloop Transportation Technologies, took a bold step ahead of the competition by claiming that it will have the world's first full-scale capsule in place by early 2018. HTT also announced its partnership with Carbures, a manufacturer that builds composite parts and structures for the automotive and aerospace industries, who will help craft the first Hyperloop pods. As a refresher, the Hyperloop concept first surfaced in 2012 from billionaire tech entrepreneur Elon Musk. Essentially, Musk's futuristic transport system would shuttle cargo or passengers through vacuum-like tubes inside capsules designed to travel at the speed of sound. The thing, though, is HTT has proven to be unrealistic before in setting and meeting its own deadlines. And although HTT was one of the first companies to release a design for a Hyperloop system, it wasn't ever able to complete its test track last year after delays and a failure to complete California's environmental review process. The company's also drawn skepticism as reports have surfaced of unpaid labor and using volunteer workers. So in summary, take HTT's promise of an early 2018 Hyperloop reveal with a grain of salt. However, that doesn't mean we won't be eagerly watching to see what happens next. Do you think HTT could realistically develop a viable Hyperloop by early 2018? For that matter, do you think any company could create a functional prototype of Musk's Hyperloop system? Tweet me your comments at MNet News or leave them in the section below.
The Massachusetts Institute of Technology probably isn't the first place you'd expect to come across while perusing a publication called Nature Plants. But MIT researchers recently took to the pages of that journal to describe new research into plant systems. Their study, however, didn't stray too far from the university's high-tech wheelhouse. MIT scientists detailed a device they named the tree-on-a-chip, a largely plastic chip that mimics the hydraulic pumping of trees and plants, which constantly direct water and sugars between their roots and leaves. The chip, researchers said, could be a precursor to the simple hydraulic actuators capable of powering small robots. Tiny robots require tiny moving parts and components that are notoriously difficult and expensive to make. But the MIT system's passive mechanism, which doesn't require external pumps or moving parts, could allow inexpensive, sugar-powered pumps to cheaply propel complex systems. Could sugar help power smaller, more nimble robots? Could this system usher in a new era of robotics and automation manufacturing? Tell us your thoughts in the comments below. That's all the time we have for today, but tune in every Tuesday and Thursday for your next Manufacturing Minute.